Doug, do you know if Munz has any gas canisters to use to fill up the balloons? A gas is a type of matter. Matter is anything that takes up space and has mass. The three types of matter you should be familiar with are solids, liquids, and gases. A solid has a fixed volume and shape. The particles are tightly packed with little free space to move past each other. For example, the tennis ball you play fetch with, this is a solid. After you play fetch, you get very tired and need a sip of water, right, Doug? Well, the water you drink is a liquid. It takes the shape of the container it occupies. The particles are close together, but unlike the solid, they slide past each other and have no regular arrangement. And the last type of matter, the one we need to fill our balloons with, is a gas. Gases have no fixed shape or volume. As you can see, there's a lot of space between the particles, allowing them to move freely with no regular arrangement. The air you breathe is a mixture of gases. Now we need to figure out which gas to use to fill our balloons. That's a good question, Doug. Let's take a look at the three characteristics of these gases. Helium is part of the noble gases. These gases all have very low chemical reactivity, helium being the second least reactive after neon. Helium is lighter than air with a density of 0.1786. Hydrogen is the lightest element with a density of 0.08988. You would think it would be used to fill balloons because of its light density. However, when hydrogen mixes with oxygen, it is very dangerous and highly flammable. Methane is also lighter than air with a density of 0.656. Like hydrogen, methane is flammable, and when 5 to 15% mixes with the air, it can be explosive, creating a pale but very hot flame. That being said, what gas do you think we should use? The density of the gases matter because in order for the balloon to float, the gases plus the weight of the balloon have to be lighter than air. This is stated in the law of buoyancy. After examining these gases, I've come to the conclusion that we should use helium. While helium isn't the lightest, it's the least reactant and safest. Okay, but there are a lot of laws. First, we have Boyle's law. This law describes the relationship between pressure and volume when the temperature and mass are constant. Volume and pressure are inversely proportional. When volume increases, pressure decreases, and vice versa. This equation shows that the product of the initial volume and pressure is equal to the product of the volume and pressure after the volume or pressure has changed, but the temperature has remained constant. So after Boyle's law, we have Charles' law dealing with volume and temperature. It states that a given volume is directly proportional to Kelvin temperature when pressure is held constant. This shows that if the pressure remains constant, the volume temperature fraction will always be the same value. Gay-Lussac's law states that pressure is directly proportional to Kelvin temperature when volume is held constant. This equation shows the pressure to temperature fraction will always be the same value when volume is constant. Avogadro's law, which states the relationship between volume and amount when both pressure and temperature are held constant. Amount and volume are directly related. If the amount of gas increases, the volume increases, and vice versa. This equation shows that when pressure and temperature are held constant, the volume amount fraction will always be the same value. Remember, amount is measured in moles. Now combining all these laws, we have the combined gas law. Pressure is inversely proportional to volume. Pressure is directly proportional to Kelvin temperature. Volume is directly proportional to Kelvin temperature. The last law is the ideal gas law. This law relates the pressure, volume, and temperature of an ideal gas. It combines Boyle's, Charles, and Avogadro's laws into one equation. P equals pressure, V equals volume, N equals number of moles, R equals gas constant, and T equals temperature. Don't worry, Doug. I have a plan.